All right. So, hello, guys. One of my viewers, the very few that I have, Diego, asked for me to run this test again with this um, maglev setup and to record some information. So, Diego, for you, the um, the rotor itself is 195 grams. Okay. The diameter is 50 millimeters and it is 55 millimeters long. So let's see, and we're setting it up here with the Hall sensor. Let's see what 5 volts will do. I don't even know if 5 volts will get it going. All right, there's 8.6 volts. So let's see what we got here. Looks like it's climbing 4,000, 4,200, 45, 46, 5,000. Still climbing. So about 5,700 RPMs at 8 volts. Let's turn it up. Actually, let's turn it down. So 6.3 volts. Okay, it's slowing down. We gotta wait for it to slow down. It takes a while. I think that's pretty good right there. So that's about 4,300 RPMs. Let's climb it up to 12 volts. It's exactly 12 volts. $62, $65, $66, starting to wobble a little bit. 7,000, 7,200, still climbing. 7,500. About 8,000, 8,200. Let's try my other tack. Yeah, 8,500, 86, 87, 88, 89, 9,000 RPM. So 195 grams, 50 millimeter diameter, 55 millimeter length. There you go, Mr. Diego. You can figure out the information from that. And we've got 9,400 RPMs at 12.1 volts. 9,500 RPMs. We'll say about 95. And this isn't even really tuned. I don't know if I have the Hall sensor in the right exact spot, but it's looking good. I think that's the first time I've ever actually took some measurements and let it climb to its max at 12 volts. Yeah, and that's using Sky Collection's coil, one of those beautiful coils. This is also his circuit. I've copied it since then, but it doesn't make any sense to use the copy when you have the real deal. And so let me set this guy up. This is that monster 4-pole or 4, oops, sorry, 4, I think they're 2.5-inch disc cylinders. And you can see the load over there lighting up. 2.5, 6. This is a Bedini coil with a iron core. And it's actually done the way John Bedini said you're supposed to do it. I don't know if it really makes a difference to have a solid core or to have these wires or these rods in there. All right, let me pause this and I will hook this guy up. Damn, phone keeps cutting out. I don't know where I lost you guys at. So I got this running down to as low as 7 volts. I could go lower, but as I said earlier, because of the distance, because this is a square and not a circle, I can't get really close. And this is a really old coil. Ideally, I'd rather put one of these pancake coils underneath it right here, which maybe I'll set up next. But I wanted to just get this guy running. And it's really firing up that I better check to make sure this circuit's not. Oh no, it's still nice and cool. It's a fantastic circuit. I believe it was invented by Mr. Sky Collection. And there's my other maglev. I gotta get that guy up and running and figure out what the top speed is for that guy. All right, let me set something else up and then we'll come back to this. All right, so I've set up this rotor with this pancake coil using a Bedini circuit. There it is right there. And it'll be charging this supercapacitor bank. So let's fire it up. And I'll be doing it at 12 volts. And let's set up the meter just to see what's going on. All right. There it goes. And so far it is, the supercapacitor bank is at 3.4 volts. We are running at exactly 12 volts. Now the bank's up to 3.5 volts. Now let me show you the circuit here. So the switch on here will let me know that that is indeed charging the bank, because if I turn it off, it lights up the protective neon bulbs, and they get hot really quick just from a second of running. We are now at 3.7 volts for the supercapacitors. That is one sweet rotor. Makes a lot of noise simply because it's bolted down, but this housing is not completely sealed with the base here, and I did that on purpose. So this is a great coil here. I can either jump it to act as a single coil, but it's a bifilar, so we're up to 3.9 volts. Yeah, at 12 volts. I don't know if I can see what the speed is on this. I don't know if this will work. It says 9,000 RPMs. I don't know if that's 7,000, yeah, around 9,000 RPM. Yeah, about 9,000. I thought it was doing more than that. So we're already up to 4 volts. And so what I'd like to do is, I did it before, but I want to do it again. I want to charge this bank up to run this system, and then also charge this bank up, this jerry rig thing that I made before I got the logic boards. But this actually works really good, this bank. It actually charges up faster than the one with the logic board. Probably not safer, but all right. I wanted to run this guy using the Bedini circuit because I've been using the JL94 circuit a lot lately. I've also been using, I haven't used the Hall circuit all that much. But let's take this off and see what we got here. Yeah, so we're at 4.2 volts on the super cap. All right, ciao. I got to get a better video setup. This thing is pissing me off. It keeps stop recording. And yeah, anyway, one of the other main reasons why I wanted to fire up a video today was to show Mr. G-Law the little demo unit that I made. So the unit doesn't function as it's supposed to, for those of you who don't know what I'm doing. So these gears do. So I printed this at 20% scale just to see how it would work. And for those who don't know, the way this would work is this planetary gear here would get physically attached to these 3 tabs, which would then, when these 3 coils are energized with the magnets that are in here, would allow this ring to move through the system. And so it would be on a stand like this, and it would be held up kind of like this. But it was, and so Mr. G-Law, a fellow from down under, sent me the files. And so before I committed to printing like 60 hours worth of files, I wanted to print a little demo unit, and it came out nice. And so here you could see this is a translucent side. You can see this is where all the barb magnets would go. These are the 3 coil housings. This is hollow, so this ring would normally slide through these. It doesn't today because, again, this is just a demo unit, and I couldn't get it to work the way I wanted to, so I settled for just this like this. And again, these 3 bases here physically tied to this planetary housing back plate, which then, when energized either in series or in parallel, I'm not really sure how we're going to do it yet, will cause this outer ring to spin or to rotate as a normal rotor would work. But it came out pretty nice. It's sweet. But since at 20%, everything seems to be working fine. You know, here, a couple little tweaks here and there. I'm going to start printing the real unit, the one that's actually going to work. And so Mr. Law there, Mr. G, has been sending updates to me, which is nice because there was a couple of things that I had in mind and he had already made the changes. So I'm going to start printing, I think I'm going to start printing the gears first, this planetary gear system. And it's set up in a way where 2 halves of the gear are printed, and it creates this little V track, which again rides perfectly in along the V track inside here. Or it wouldn't ride, it would cause this to spin. If it doesn't make any sense, no worries, it will at some point. But everything lines up at 20%, which I was amazed. I was absolutely amazed. Mr. Law, your design skills are off the hook. They are really good. This thing doesn't do it justice, but it does serve as a little demo unit for my own brain. Anyway, that was one of the other reasons other than testing Mr. Diego's request. All right, ciao.